So, good morning, students. We'll start our topic number 7 of Unit 4, which is Building Information Modeling BIM in Project Management. So, the first topic is use of BIM, that is Building Information Modeling in a Project Management. BIM, Building Information Modeling, has been revolutionizing the AEC industry, that is the construction industry, in terms of economic and technical viability over the past few years. The advantages of the long-term application of BIM can be leveraged most efficiently in the field of project management. The need for management of an asset is a continuous process from inception to demolition, a true cradle to grave cycle which involves handling large volumes of data, handling a lot of responsibilities, and so on, for which BIM is the one-stop solution. Project managers need to embrace building information modeling, interrogate the BIM information, and reap the maximum benefits out of it for effective project management. Number two, there are two broad aspects of building information modeling which enables it in facilitating project management. BIM facilitates IPD, that is Integrated Project Delivery. So IPD is a proven method when it comes to project management. An integrated project delivery plan which brings together different disciplines and efforts and integrates all parties, including project managers, designers, engineers, systems, and practices under a single umbrella, creating a win-win situation for all the involved personnel. So when IPD and BIM are used in conjunction or in coordination, the expectations for the project to be completed successfully are increased. BIM seeks to facilitate the exchange of information between all parties to a construction project with the goals of reduced cost, error, and redundancy. BIM is an effective tool for combining the detailed information available from all the parties into an intelligent integrated model, which in turn improves the productivity of a project team. The technical aspects of BIM. Building information modeling has some sophisticated technical aspects which can greatly facilitate project management. The quick summary of which is given below. The first one is clash detection. The inconsistencies in the geometrical designs of the various disciplines of a building is the most commonly seen problem in an AEC industry. This happens because of an overlap between the different plans. The only feasible solution for this issue would be to use BIM and bring the plans together in a cloud and detect any discrepancies and make the necessary changes. Number two, constructability. Building information modeling provides a platform to carry out constructability reviews and monitor constructability. Building information modeling allows for a better analysis. So BIM allows engineers and designers a better visual analysis of a building and facilitates better decision making, starting from the energy consumption details to optimum lighting conditions needed. BIM helps to find better solutions such as changing materials and orientation, mass and space, etc. for every problem. 4D and 5D modeling. One of the most unique features of BIM modeling can offer is 4D and 5D modeling. A 4D model allows an engineer to evaluate the progress of a construction project and have a clear understanding of the project phases. 5D BIM model allows cost evaluation of a project and can help in determining the lowest cost solutions. So essentially, building information modeling facilitates simulation of various alternatives for a construction project and helps project managers and executives to reliably predict the consequences of their decision. Next, quantity takeoff. Quantity takeoffs available in a BIM model can be of assistance to the project teams and managers in analyzing their decisions and facilitate a clear and reliable insight to various alternatives in the design phase or even throughout the project lifecycle. Since there is a possibility of integration between the BIM model and a database containing cost estimation, an accurate estimation can be obtained faster. The advantages of BIM in project management includes improved collaboration and control among project stakeholders, improved project quality, faster delivery of projects, cost-effective method, reducing waste of resources, and maximum revenue and new business opportunities. Building information modeling, apart from being a great tool of assistance in technical aspects of construction, can also be used as an effective project management tool. So the technical aspects of BIM such as clash detection, 4D and 5D modeling, quantity takeoff, etc. can be very useful for project management. It is for these reasons people who wish to pursue a career in project management should have a clear understanding of how to use BIM tools in project management. So BIM encompasses the following subdivisions. The first one, documentation, fabrication, construction or in 4D or 5D, construction logistics, operation and maintenance, demolition, renovation, programming, conceptual design, detailed design, and analysis. Disadvantages of BIM. Incompatibility with partners. So BIM is not yet universally used among construction professionals. There is always the possibility that one of your partners or subcontractors may not use BIM and may not be able to use your models. Number two, legal issues. The legal ramifications of using BIM software have not yet been extensively tested, let alone settled. Number three, cost of software. BIM software requires a substantial investment in new technology. The advantages usually make the investment worthwhile, but only if the software is used to its full capacity. Number four, lack of experts. The relative newness of a BIM means that there are a limited number of experts working in the field. So your software purchase may require an additional investment in training and education. The future of BIM. Because of the clear benefits, BIM is definitely here to stay, and it has defined goals and objectives that are clearly beneficial to all those who work their way through the levels. So undoubtedly the future of construction will be even more highly collaborative and digital. So as BIM becomes increasingly more sophisticated, 4D, 5D and even 6D BIM will start to play a part in the process. Furthermore, around the globe, there is an attempt to reduce waste in construction. Much of this is attributed to supply chain inefficiencies, clashes, and reworking. By working collaboratively in a BIM environment, all of this becomes much less likely, setting the stage for a better tomorrow. So you can give your attendance now in the chat box. Thank you.
BIM, or Building Information Modeling, has been making headlines across the construction industry for some time now. You might have read about it in construction magazines or heard about it during engineering or architecture conferences. Some of you might already be using BIM for your projects. We thought it would be a good idea to make a short video about what exactly building information modeling is and how it is useful for engineers, architects, and construction professionals. To explain the video, we have used simulations that were kindly provided by the cloud-based simulation provider Simscale. Let's start with the basics. What exactly is building information modeling, or BIM? In simple terms, BIM is a digital representation of a building's physical and functional properties and characteristics. BIM goes further than just the building's physical appearance and includes information about every component that goes into a project. This helps the designer, whether it's an architect, engineer, or construction professional, to create and design more effectively when compared to other tools on the market today. Every component of a building is essentially a BIM object. This means you could take a window, a door, or an HVAC system as an example, and the file will tell you the product's properties, like thermal performance, its physical characteristics, a graphical representation of what the product actually looks like, product's functional data, allowing the user to manipulate the object, the way it was intended to be used. So we can say that BIM is first and foremost a process, but it's much more than that. BIM is a 3D modeling based process that provides architecture, engineering, and construction professionals information and tools to efficiently plan, design, construct, and manage buildings and structures. The essence of the BIM process is that it enables the creation of virtual 3D models that can be explored and manipulated, making it easier to understand the relations between spaces, materials, and systems. A database generates a 3D image and creates building plans. Thus, the BIM process can build, view, and test a structure in 3D. Constructabilities allow revisions and the assembly of accurate details. The detailed data permits design, clash detection, cost, and scheduling. Each of the stages of design and construction benefit from its involvement in BIM. The most known BIM software solutions are Revit, Navisworks, Autodesk BIM 360, SketchUp, as well as ArchiCAD and Vectorworks Architect. As technology continues to advance, computer-aided engineering, CAE, software is also becoming part of the construction industry. CAE, also called engineering simulation, is being used by engineers and architects to predict wind loads on buildings, ensure pedestrian comfort in urban areas, validate HVAC systems, control air quality and contamination in clean rooms, laboratories, or underground spaces, predict smoke spread, and optimize thermal comfort. Although not usually integrated with BIM software yet, simulation tools are becoming more and more accessible through cloud computing. One example is Simscale, the world's first production-ready software as a service application for engineering simulation. By providing instant access to computational fluid dynamics, or CFD, and finite element analysis, FEA, Simscale has moved high-fidelity physics simulation technology from a complex and cost-prohibitive desktop application only available to experts in large companies to a user-friendly web application accessible to any designer and any engineer in the world via a pay-as-you-go pricing model. Here are a few applications. HVAC system. This video shows the comparison of two ducting designs that were simulated for an inlet velocity of 5 meters per second with the Simscale platform. The blue region on the velocity bar represents the low velocity region, while the red region represents the high velocity region. The first design is an unoptimized one which has sharp angles, while the second design, optimized, is a more curvy one. Pedestrian wind comfort. The Flatiron building in New York generates very strong winds. The building splits Broadway and Fifth Avenue and sits at the end of an open corridor created by Madison Square Park at the north. At this location, winds tend to be very high. In the case shown, the wind flow direction is from the north, but slightly aligned with the Broadway street. This produces the most interesting effects as the flow encounters the unique front shape. The animation kindly provided by Simscale shows the flow speed, where the red color shows the higher flow speeds. In these conditions, the wind gusts reach the front leading edge / cone shape of the building that creates accelerated flow and vortices on the Broadway and especially Fifth Avenue side. Wind loads on buildings. We can see the main effects of the structure optimization in this animation that shows the flow physics at 3 different cross sections along the height. Close to the base height level, the area is the largest, and so is the weight behind the structure. But the corner softening helps to avoid strong vortexes. At mid-height, the cross-sectional area not only decreases, but also changes between symmetric and non-symmetric form. In this animation, a non-symmetric section is highlighted that shows non-coherent vortex shedding. This helps to spread out the frequencies along the height and avoid a single dominant oscillation. At the very top, the wind speeds are the highest, but as the cross-section area is rather small due to tapering, the forces are thus small also. Combined together, the structure is very well optimized with wind loading and is effective in taming the wind. Let me tell you a little bit about Simscale. From CAD upload to post-processing, the entire simulation process with Simscale happens in a standard web browser. Being cloud-based, the platform eliminates the hurdles that accompany traditional simulation tools, such as high installation costs, licensing fees, deployment of high-performance computing hardware, and required updates and maintenance. With over 150,000 individual users worldwide, Simscale has become an integral part of the design validation process for thousands of successful companies worldwide, such as WSP, Thornton Tomasetti, Arup, L&T, or Acceptance Group. The platform is used by engineers, architects, and designers who want to easily test and optimize their designs early in the design process, thus also reducing the number of physical prototypes required. Simscale is determined to make engineering simulation more accessible so that everyone can design better products faster and cheaper. To that end, it provides a free community account which can be created in 3 minutes, many learning resources from thousands of public projects that can be copied and used as templates to weekly webinars, courses, and tutorials. Give it a try by following the links in the video's description.
Today we're going to learn about BIM, or Building Information Modeling, one of the advancements in construction technology that the digital age has brought to us. BIM is not a new idea or concept. It has been with us for many years now. The developments in technology have enabled the construction industry to plan, design, construct, and manage more complex and larger scale projects. Every year, more and more professionals in architecture, architectural technology, building surveying, quantity surveying, construction management, and property development and planning are implementing BIM. Increasing the efficiency of projects, improving collaboration between different stakeholders, and creating a central model that contains all the project information are only some of the added values of implementing BIM. So, what is BIM? BIM is evolution, not revolution. It was developed over many years by various scholars from all over the globe who worked hand in hand with software developers. The first BIM concept that appeared on PCs was in 1984. 2 years later, in 1986, Robert Eich introduced the term building modeling for the first time. Building performance data appeared on early BIM applications in 1993. The golden years of BIM development were from late 1990s to early 2000s. In 2004, collaboration on central models appeared on BIM applications. The advancements of BIM accelerated considerably from that point, And in 2008, more cutting-edge technologies such as parametric modeling and laser scanning were incorporated into BIM applications. After 2015, different governments made amendments to the existing construction regulations to improve the incorporation of BIM process. For example, in 2016, use of BIM process in funded projects became mandatory in the UK. In 2020, Germany made it compulsory for transportation projects to use the BIM process. While there are different definitions of BIM, it is a process that improves collaboration between different stakeholders throughout building's life cycle. BIM is a process of working together to advance the efficiency of construction projects. The most important element of a BIM process is a BIM model that contains all building information. So here are two important questions. What can we do with a building model? And what building information can be integrated into a digital model? The answer to both questions is everything. A BIM model includes a detailed 3D model with all architectural and structural elements, mechanical and electrical systems, spaces, details, schedules, and all sorts of documentations. It can easily calculate cost estimation, material quantities, energy performance, etc. Is BIM only useful for large and complex projects? Absolutely not. Implementing BIM is highly beneficial for different types of projects with various functions and scales. Is BIM useful for small-scale projects? Yes, and here are some more detailed answers to these questions. Scan to BIM for real-time surveying and incorporation of site features creates a huge potential to design and construct spaces that are perfectly integrated with various site-specific conditions. Implementing BIM will also increase project precision and accuracy, less errors and mistakes. It will also improve the coordination between different disciplines involved in a project, which will eventually result in minimizing time and cost of the projects. Using BIM, we can have planned overlaps between different stages of the project, which results in reducing the project time and cost. Let's discuss some of the many issues the construction industry was facing before the implementation of BIM. Incompatible IT systems, lots of problems around file sharing and different file formats. Extensive use of paper, email overload as more conversations were required among different stakeholders, low data security and unclear modern data ownership, low transparency of information flow, loss of revision documents, limited project records, and finally, there was no central model containing all project information. Using one system of digital models increases the synchronization between various documents produced by different professionals involved in a project. BIM is the process of designing, constructing, and managing a building or infrastructure collaboratively using advanced linked digital models. I hope you enjoyed the video and found it useful and informative. In the next series of videos, I will explain BIM capabilities in more details, its various dimensions and applications.